So this lesson is on the end behavior of graphs. So it might be self-explanatory, but end behavior means how it ends. Okay, so a positive even would be something like this, x squared. And we know that that graph would be a parabola that looks something like this. So here's what the end behavior means. At the start of this, right here, that's where it's starting, it's positive. Or sometimes you would just put a plus sign or an up sign or whatever. Then at the end of this side, it's also going to be positive. So it's like reading a book where we start on the left and we end on the right. Okay, so let's say that we have a negative even. So something like negative x to the fourth. That graph might look something like this. So same thing, starting on the left for the start. Well, this is a negative and it is down, so it's negative. When I end, I'm over here. This is also negative. It's pointing down. So what you're going to notice with the positive even and the negative even, whatever it is, it's going to match. They're going to be the same thing. They're both going to be positive or they're both going to be negative. So let's look at a positive odd. So something like x to the third. Here's what that graph looks like. Any graph, x to the third. Okay, so with an odd, you're going to have different things. Here's where we're starting. On the left, we're going to start negative. Then it's going to end positive. So the way that you can remember that is the positive is going to be the end behavior. So as we look at the next one, it's going to be the same thing. So if I had negative x to the fifth, that's going to look something like that. On the left-hand side when we start, we're starting positive and we're ending negative. Same thing. It's a negative odd, so it's going to end negative. That's kind of the trick to remembering that. Okay, so the number of turning points something has. So with the number of turning points, it's always going to be one less than the highest exponent. One less than the highest exponent. Okay, so if I have x to the third, here's what an x to the third graph looks like. Something like this. So its turning points, it's going to turn here once, it's going to turn here twice. It has two turns. It was x to the third. One less than that is 2. Same thing on the next one. X to the fourth. We said it was going to look like something like this. Its turning points, there's 1, 2, 3 turns. That's one less than the highest exponent. X to the fifth might look something like this. It has 1, 2, 3, 4 turns. One less than the highest exponent. X to the sixth. Something like this. 1, 2, 3, 4, 5 turns. One less than your highest exponent. Okay, so that's pretty easy. The harder part is describing how these graphs rise and fall. So there's 2 different ways to do it. You can do it with arrow notation, or you can do it with the rise and fall method. So here's what you know. Okay, first, this graph is a parabola. It's x squared, and it's negative. So it's a negative, and its highest exponent says that it's even. So this is a negative even. So here's what this looks like. Negative and even. It's a parabola that opens down. So the fall method says it's going to fall to the left. That's this part. And it's going to fall to the right. That's this portion. Okay, let's look at another one. X to the fifth. So what that graph would look like, we know what that looks like. So from this, first, there's nothing out in front of this, so it's a positive function. It's raised to the fifth, so it's odd. A positive odd function does 2 different things. It is positive at the end, its end behavior is positive, and it does 2 things. So on the left-hand side, that's this. It's going to fall left. On the right-hand side, that's over here, it's going to rise to the right. So that's rise and fall method, describing it with rising and falling. Now let's go with infinity notation. Infinity notation is a little bit tricky. So on the left-hand side, okay, the left-hand side of the graph is still our red. That's what we're looking at. That's negative infinity. So you say f of x. That means the function. As it goes to negative infinity, then x also goes to negative infinity. Okay, so as the function goes negative, the y goes negative. That's this part right here. Okay, so let's look at our green then. That one, as the function is also going to negative infinity, my x value is going to positive infinity. So let's break that down a little bit more. This is saying as x gets bigger, the function goes down. This is the x gets bigger. This part is the function goes down. Whereas this one, x gets smaller, it's going to negative numbers. It's going negative 10, negative 20, negative a million. It's still, the function goes down. Okay, so then let's look at our other one. Getting a little bit cramped here. So this one, as the function goes to negative infinity, the x values are also going to negative infinity. That's matching this part. So as the function goes down, the x values are getting more and more negative. Whereas the other part, as the function goes to positive infinity, the x value goes to positive infinity. That's this part. Okay, so the bottom one is saying as x gets bigger, so as x goes to 10, goes to 15, goes to 20, the function goes up. And that's the end part of that that's going up over here. Okay, so the infinity notation is a little bit tricky, but if you can understand the rise and fall, that's really going to help you with the function notation itself.